Good morning dear students, welcome for the physics class. Today we are going to discuss a potential energy of a bar magnet kept in a uniform magnetic field. Okay. In previous classes we have studied about the time period of a bar magnet kept in a uniform magnetic field and also the frequency of a oscillation of a bar magnet which is kept in a uniform magnetic field. So whenever we kept a bar magnet in a uniform magnetic field with an angle between the axis of the magnet and the uniform magnetic field, at the time there will be a torque acting on a bar magnet which will produce us simple harmonic motion, means SHM oscillations in case of the bar magnet. Okay, so during such oscillations there is a one more factor involvement we will find, that is moment of inertia, right? So whenever we keep a bar magnet in a uniform magnetic field, it will start to oscillate like this. Okay, so here we already seen how to find out the time period of the bar magnet which is oscillating simple harmonically, and how to find out the frequency of that oscillations already we have studied. So today we will study how to find out the potential energy in case of such a bar magnet which is placed in a uniform magnetic field. Okay. So here, in first case you already have studied that the potential energy will be equal to the amount of work done. In a simple linear movement case, the work done will be force into displacement. But here we are finding the angular displacement. Angular displacement. So the work done will be, instead of force, we need to consider torque. In place of linear displacement, we need to consider angular displacement. So that is, first we know that potential energy is equal to work done. Okay. So now this potential energy will be represented with the help of U, alphabet U. So which is equal to torque into displacement, angular displacement. So first we will consider for the small angular displacement d theta. For small angular displacement d theta, torque into small angular displacement, that is d theta. So that is U is equal to tau into d theta. So which is equal to tau. What is the value of tau? Already in previous class we have discussed about the torque. That is tau is equal to mb sin theta. So m means the magnetic moment and b means the strength of the external uniform magnetic field. So and d theta. So it is for the small displacement. If you consider the total displacement, that is theta, for total displacement theta, so we need to integrate this one. So here I will consider this as a du, the small potential energy for the small displacement. So now in order to get the total potential, we need to integrate this du, that is integration of mb sin theta into d theta. So here mb is the constant. Take it outside. Integration of sin theta is minus cos theta. Okay. So it is what? It is the expression for the total potential energy of a bar magnet which is kept in a uniform magnetic field. Okay. This one is. And here we'll have some of the special cases. Those special cases depends on the angle between the axis of the magnet and the direction of uniform magnetic field. So special cases. So here I consider case 1. In case 1, if theta is equal to 0 degree, then u is equal to minus mb cos 0. Cos 0 means how much? 1. Right? So that will be minus mb. So this is minimum potential energy. Second case, if theta is 180 degree, then u is equal to minus mb into cos 180. Cos 180 is minus 1. So that minus 1 into this minus will become plus. So this is maximum potential energy. Okay. When can we get the maximum potential energy for a bar magnet kept in a uniform magnetic field? When theta is 180 degree. When can we get the minimum? When theta is 0 degree. So if third case, if theta is equal to 90 degree, then u is equal to minus mb into cos 90 is how much? 0. Then 0 into mb is 0. So u is equal to 0. So this is 0 potential energy. 0 potential energy. Is it clear? Okay. Next, we'll go for the next concept, that is magnetic flux. What do you mean by magnetic flux? Next one is magnetic flux. Magnetic flux means that is the number of magnetic field lines passing normal through any surface is called as magnetic flux. If you have the magnetic field lines and those field lines were passing normally through any surface, then those field lines are called as magnetic flux. So here one more thing. When can we get the maximum magnetic flux? When the field lines were having exactly 90 degree with the surface area. 90 degree with the surface area means the field line should be perpendicular to the surface area. Then we will get the maximum magnetic flux. Then when can we get the zero magnetic flux or the minimum magnetic flux? When the magnetic field lines were parallel to the surface. Nodri, the surface idre field lines ee tara idvu antandre parallel idvu antandre avaga we are going to get the minimum magnetic flux or the zero magnetic flux. But whenever the field lines were exactly perpendicular, at that time we get the maximum magnetic flux. Okay. The number of magnetic field lines passing normally through the given surface. The number of magnetic field lines passing normally through a given surface is called as of the important factor or one of the important concept, that is Gauss law in magnetostatics. We find Gauss law in electrostatics also. Already we have studied that in first and second chapter. First chapter we have studied, and second chapter somewhere we will find the application of Gauss law in electrostatics. But here in magnetostatics also we have a Gauss law. What it tells? The net magnetic flux through any closed surface is zero. The net magnetic flux through any closed surface is zero. It is the statement. Okay, that is, you can write that as a pi is equal to surface integral of b ds is equal to 0. b ds is equal to 0. It is the statement. It can be asked for 1 marks. If they have asked for 1 marks, simply have to write the statement and this equation. If they have asked for 3 marks, a little bit explanation is there. We will go through that explanation. So just consider a Gaussian surface. Okay. So here we have number of magnetic field lines passing through that Gaussian surface, a closed surface, right? So let me consider the magnitude of the field will be B. Now the total area of this closed surface, we take that as a S. Now just consider a small area element, whose area is ds, and here I consider the area vector. So angle here I consider theta. Now how to just imagine this theta will be 0 degree. Okay, that means the field lines are exactly perpendicular to the surface. The field lines are exactly perpendicular to the surface. Okay, so when these field lines are perpendicular to the surface, then this area vector is going to align parallelly with respect to the magnetic field direction. The theta will be 0. Okay, so now the magnetic flux through this area element ds, I'll consider that as a small magnetic flux d pi, which is equal to b into area, that is bds. Now what will be the total magnetic flux through this closed surface? So here this entire surface is made up of number of small area elements like ds. Then the magnetic flux through each area element ds, together we are going to get the total magnetic flux through the entire closed surface, right? So that is total flux pi is equal to addition means integration, surface integration of d into ds. Okay, now according to Gauss statement, what is the value of this PDS? Which is equal to 0. Is it clear? If they have asked for 3 marks, you have to write this one. And the description part I have provided in the notes. Please go through the notes. Okay. Okay. I'll make it simplest. Okay. ಇದೇನು ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದೆಯಲ್ಲ, ವಾಟ್ ಇಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಮೀನ್ಸ್ ಅಂತ ಹೇಳಿದರೆ, ಸೊ ಜಸ್ಟ್ ಕನ್ಸಿಡರ್ ಅ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್. ಸೊ ಹಿಯರ್ ಐ ಕನ್ಸಿಡರ್ ಅ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ with north and south pole. What is the direction of field? So start from north and ends at south, like this. Start from north and ends at south. So according to Gauss law, we can say here the number of incoming field lines is equal to number of outgoing field lines. Number of incoming field lines, ಎಷ್ಟು ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಒಳಗಡೆ ಬರ್ತಾವೋ ಅಷ್ಟೇ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಹೊರಗಡೆ ಹೋಗ್ತಾವು. ಆಸ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ಹೌ ಮೆನಿ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ were coming inside the surface? 1 and 2. And how many field lines were going outside from the surface? 1 and 2. ಎರಡು ಒಳಗಡೆ ಬರ್ತಾ ಇದ್ರು, ಎರಡು ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದ್ರು. ಎಷ್ಟು ಬಂತು ಅಷ್ಟೇ ಹೊರಗಡೆ ಹೋಯ್ತು ಅಂತಂದ್ರೆ what is the net flux through the surface? 0. The net flux through the surface is 0. It is the actual meaning of Gauss law in magnetostatics. Okay. Okay. So the next concept is Earth's magnetic field. So here, Earth is also having certain magnetic field. Okay. So Earth can be considered as a huge magnet because it is having a magnetic field. It acts as a magnet. So Earth is considered to be a huge magnet having the magnetic field of the order of 10 to the power minus 5 Tesla. So it is the value of the magnetic field due to Earth. Okay. And so you can look here, I have drawn a diagram. So here, in earlier days, they used to consider that a huge bar magnet is buried deeply inside the Earth. A huge bar magnet is buried deeply inside the Earth in such a way that the magnetic axis, as you can find here, the dotted line indicates the magnetic axis and the straight line indicates the geographic axis. So, geographic axis. Geographic means Earth axis, right? So huge bar magnet is buried deeply inside the Earth in such a way that the axis of the magnet is almost close to the axis of the Earth. As you can see here, the angle between the Earth's axis, geographic axis, and the magnet axis is a very small, that is 11.30 degree. Okay, so that means those are aligning very close to each other, and the magnetic field lines coming out from the Earth's surface, from the Earth, is almost similar to the magnetic field lines produced due to the huge bar magnet which is buried deeply inside the Earth. Okay, so as you can see here, so dotted line indicates, dotted circle indicates the magnetic equator, and the straight or uncut circle indicates the geographic equator or Earth's equator. ಏನು ತಿಳಿದಿದ್ರು ಮುಂಚಿನ ಕಾಲದಲ್ಲಿ ಅಂದರೆ ಒಂದು ದೊಡ್ಡ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟು ಅರ್ತ್ ಒಳಗೆ ಹೋಗದಾರ. ಯಾವ ಥರ ಹೋಗದಾರ ಅಂತಂದರೆ ಆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟಿಂದ ಆಕ್ಸಿಸ್ ಏನಿರ್ತದಲ್ಲ ಅದು ಅರ್ತ್ನ ಆಕ್ಸಿಸ್, ಅರ್ತ್ ಆಕ್ಸಿಸ್ ಅಂದರೆ ನಾರ್ತ್ ಟು ಸೌತ್ ಪೋಲ್, ಜಿಯೋಗ್ರಫಿಕ್ ನಾರ್ತ್ ಜಿಯೋಗ್ರಫಿಕ್ ಪೋಲ್ ಟು ಜಿಯೋಗ್ರಫಿಕ್ ಸೌತ್ ಪೋಲ್ ಥ್ರೂ ಹಾಗೆ ಹೋಗುವಂಗೆ ಒಂದು ಆಕ್ಸಿಸ್ ಡ್ರಾ ಮಾಡಿದ್ವಿ ಅಂದರೆ ಅರ್ತಿಗೆ, ಆ ಅರ್ತಿನ ಆಕ್ಸಿಸು ಮತ್ತು ಆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟಿನ ಆಕ್ಸಿಸು ಆಲ್ಮೋಸ್ಟ್ ಎರಡು ಕ್ಲೋಸ್ ಇರ್ತಾವು, ರೈಟ್. ಆ್ಯಂಡ್ ನಾವೇನು ಅರ್ತ್ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅರ್ತ್ಗೆ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಲುಕ್ ಹಿಯರ್ ಅರ್ತ್ಗೆ ನಾವು ಈ ತರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಏನು ನಮಗೆ ಪ್ಯಾಟರ್ನ್ ಸಿಗ್ತದಲ್ಲ, ಸೊ ದ್ಯಾಟ್ ಪ್ಯಾಟರ್ನ್ ವಿಲ್ ಬಿ ಲುಕ್ಸ್ ಲೈಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಡ್ಯೂ ಟು ದಿ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್. ನೋಡಿ, ಬಾರ್ ಮ್ಯಾಗ್ನೆಟಿನ ನಾವು ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಡ್ರಾ ಮಾಡಿದ್ವಿ ಅಂದ್ಕೊಳ್ಳಿ. ಆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟಿನ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಮತ್ತು ಅರ್ತಿನ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಸೇಮ್ ಇರ್ತವು, ಸೇಮ್ ಪ್ಯಾಟರ್ನ್ ಇರ್ತೈತಿ ಅಂತ ಹೇಳ್ತಾರೆ ಅವರು. Okay, then the pole of the magnet which is towards the north pole of the earth is called as north magnetic pole, and the pole which is towards the south pole of the earth which is south magnetic pole. So here the direction of the lines like this, north to south. Is it clear? Then here, this imagined huge buried magnet has its north and south poles, and those poles were magnetic poles were approximately 2000 kilometers away from the geographic poles. So magnetic poles were approximately 2000 kilometers away from the geographic poles. So here north magnetic pole will lie somewhere at northern part of the Canada. Northern part of Canada will have the north pole of the bar magnet which is buried deeply inside the earth, and the south pole of the magnet, bar magnet, will find somewhere in Antarctica. ಲಾಸ್ಟ್ ಖಂಡ ಏನು ಬರ್ತದೆ ಕಾಂಟಿನೆಂಟ್ ಅಂಟಾರ್ಟಿಕಾ ಅಂತ ಕರಿತೀವಿ, ಅಲ್ಲಿ ನಮಗೆ ಸೌತ್ ಪೋಲ್ ಸಿಗ್ತದೆ. ಸೊ ಈ ಮ್ಯಾಗ್ನೆಟಿನ ಪೋಲ್ಸು ಅರ್ತಿನ ಪೋಲ್ಸ್ಗೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 2000 ಕಿಲೋಮೀಟರ್ ದೂರದೊಳಗಿರ್ತಾವೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ಅದ್ರದ್ದು ಎಕ್ಸಾಕ್ಟ್ ಲೊಕೇಶನ್ ಹೇಳಬೇಕಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ನಾರ್ತ್ ಪೋಲ್ ಆಫ್ ದ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ವಿಲ್ ಲೈ ಅಟ್ 79.4 ಡಿಗ್ರಿ ನಾರ್ತ್ ಲ್ಯಾಟಿಟ್ಯೂಡ್ and 71.8 degree west longitude. What it is? North pole of magnet. Then south pole of magnet. South pole of bar magnet, which we find exactly at 79.74 degree south latitude and 108.22 degree east longitude. ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಅಂತ ಹೇಳಿದ್ರೆ ನೋಡಿ ಅಕ್ಷಾಂಶ ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಅಂತಂದ್ರೆ, ಲಾಂಜಿಟ್ಯೂಡ್ ಅಂತ ಹೇಳಿದ್ರೆ ರೇಖಾಂಶ. ಅಕ್ಷಾಂಶ ರೇಖಾಂಶ ಆಲ್ರೆಡಿ ಸ್ಟಡಿ ಮಾಡಿದ್ದೀವಿ ಸೋಷಿಯಲ್ ಸೈನ್ಸ್ ಒಳಗೆ, ಜಿಯೋಗ್ರಫಿ ಒಳಗಡೆ, ಹೈಸ್ಕೂಲ್ ಒಳಗೆ, ಹೌದಾ? ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದ ಎಕ್ಸಾಕ್ಟ್ place where we can find the north and south magnetic poles. Okay, right. Then what is the cause for Earth's magnetism? What is the cause for Earth's magnetism? So till today nobody has explained the exact reason for the magnetic property of Earth or Earth's magnetism. Nobody has explained the exact reason with proof, but there will be some assumptions. ಹಳೆ ಕಾಲದಲ್ಲಿ ಏನು ಮಾಡಿದ್ರು, ಯಾರೋ ಒಂದು ಮ್ಯಾಗ್ನೆಟನ್ನು ಅರ್ತ್ ಒಳಗಡೆ ಹೋಗಿದ್ದಾರೆ, ಅಥವಾ
ಇನ್ಬಿಲ್ಟ್ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಐತಿ. ಸೊ ಅದರಿಂದ ಅರ್ತಿಗೆ ಏನು ಬರ್ತದೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬರ್ತದೆ ಅಂತ ಮಾತಾಡ್ತಿದ್ರು. ಮತ್ತು ಇನ್ನೂ ಒಂದೆರಡು ರೀಸನ್ ಕೊಡ್ತಾರೆ. ಏನಪ್ಪ ಅಂತಂದ್ರೆ rotation of earth is responsible for the magnetic property of earth ಅಂತ ಹೇಳಿ ಕರೀತಾರೆ. ಯಾಕೆ ಹೆಂಗೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, every material is made up of atoms constitutes what? Charge. Okay, so charge restನಾಗ ಅದಾವ ಇಲ್ಲ, charges were continuously moving. If the whole material is moving means an additional movement will be given for those charge which are already in motion. ಹೌದಾ? So each charge will act as a current loop. Obviously earth also made up of atoms, and atoms, huge number of atoms, uncountable infinite number of atoms, and those infinite number of atoms have an infinite number of charge. All those charges were moving, and all those charges were moving with the earth surface also. Then they are responsible for the current. They will be acts as a current loop. Wherever we can find the current, there will find the magnetic field, right? So this is the one of the assumed reason. Due to the motion of these charges which are inside the atoms inside the earth surface were moving, and each charge acts as a current loop. Due to that current, the earth is going to have the magnetic field or the magnetic property, which is one of the assumption. In the second assumption one is current flow due to convection flow of the metallic fluids. Inside the earth will have the molten form of the fluids. Molten form of iron we have, molten form of nickel we have inside the earth. The convection flow of those molten iron and nickel means the fluids is responsible for the flow of current, and these phenomena is called as dynamo effect. ಏನು ಕನ್ವೆಕ್ಷನ್ ಫ್ಲೋ ಆಫ್ ಫ್ಲೂಯಿಡ್ಸ್ ಇರ್ತದಲ್ಲ ಇನ್ಸೈಡ್ ದ ಅರ್ತ್ ಸರ್ಫೇಸ್, ಏನು ಕನ್ವೆಕ್ಷನ್ ಫ್ಲೋ ಆಫ್ ಮೆಟಾಲಿಕ್ ಫ್ಲೂಯಿಡ್ಸ್ ಇರ್ತದಲ್ಲ, ದಟ್ ಈಸ್ ಮೋಲ್ಟನ್ ಐರನ್ ಆಗಿರ್ಬೋದು, ಮೋಲ್ಟನ್ ನಿಕ್ಕಲ್ ಆಗಿರ್ಬೋದು, ಅದ್ರದ್ದು ಕನ್ವೆಕ್ಷನ್ ಫ್ಲೋ ಏನು ಆಗ್ತದಲ್ಲ, ದ್ಯಾಟ್ ಈಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ದ current, and this is called as dynamo effect. And due to that current we are going to have the magnetic property for the earth. So these are the some of the assumptions, but exactly adena annodana helik agilla innu. So next one is a very important concept, that is earth's magnetic elements. It will be again and again asked in our annual examination. The question will be asked on this concept. Okay, so 1 or 2 marks. ಏನಂತ ಕೇಳ್ತಾನೆ, ರೈಟ್ ದ ಅರ್ತ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕೇಳ್ತಾನೆ, ಗೊತ್ತಾಯ್ತಾ? ಅಥವಾ ಡಿಫೈನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ಕ್ಲೈನೇಷನ್ ಆರ್ ಡಿಪ್ ಅಂತ ಕೇಳ್ತಾನೆ. ಏನಪ್ಪ ಅರ್ತ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ these are the quantities which represents magnitude and direction of the magnetic field at any point on the earth surface. ಅರ್ತ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಯಾವುದೇ ಪಾಯಿಂಟಿಗೆ ಹೋದರೂ ಕೂಡ ಅಲ್ಲಿ ನಾವು ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅದ, ಯಾವ ಡೈರೆಕ್ಷನ್ನಾಗ ಅದ ಆ ಫೀಲ್ಡು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ವಿ ಮಸ್ಟ್ ಹ್ಯಾವ್ ದ ನಾಲೆಜ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡಿಕ್ಲೈನೇಷನ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ಕ್ಲೈನೇಷನ್ ಆರ್ ಡಿಪ್, ಆ್ಯಂಡ್ ಒನ್ ಮೋರ್ ಈಸ್ ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ಆಫ್ ಅರ್ತ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ field. Okay, these are the quantities which represents the magnitude and direction of the magnetic field at any point on the earth surface. Is it clear? Okay, the first one is magnetic declination, and that will be indicated by delta. And next one is magnetic inclination. This inclination also called as dip, magnetic dip. Okay, magnetic dip andru onde, magnetic inclination andru onde, and that we are going to represent with the help of theta. And third one is horizontal component of earth's magnetic field, and that is going to represent with B subscript H. What do you mean by magnetic declination? Delta. It is the angle made between the geographic meridian and the magnetic meridian. What is the meridian? Meridian means it is an imaginary plane. Meridian means it is an imaginary plane passing through the poles of the magnet or poles of the earth. Okay, earth meridian means we have considered any point. We have considered at Jagalur only. In Jagalur or in Bangalore, we want to find out the magnetic field. Then we must draw the imaginary plane which is passing through the poles of the earth as well as passing through the Bangalore. It is an imaginary plane passing through the poles of the earth and passing through the Bangalore. Right? It's called as geographic meridian. Not only Bangalore, you can consider any place. If you want to find out the magnetic field at any place, then you have to draw an imaginary plane passing through both poles of the earth and also through that place. That is called as geographic meridian. And also the magnetic meridian means it is an imaginary plane passing through the poles of the magnet and also through that place where we are finding the magnetic field. Okay, so you can look here. This is the schematic diagram of the Earth's magnetic elements. Okay, this rectangular, the uncut diagram is a magnetic meridian, and this one, the cut lines. Okay, these lines, these rectangle will represent the geographic meridian. The dotted line indicates the geographic meridian. Why I have made such an angle here? Because already in previous diagram we have studied the axis of magnet and axis of earth were almost close, but there will be certain angle, that is 11.3 degree, right? So that's why here in between the geographic meridian and the magnetic meridian also will get a certain angle. Okay, so that is delta. So delta is the angle between geographic meridian and magnetic meridian, and that is called as magnetic declination. And next one, so I'll go for the third one. Afterwards, I'll move to the second one. Horizontal component of Earth's magnetic field. So Earth's magnetic field. Earth ಇವಾಗ ಯಾವ ತರ ಇರ್ತದೆ? ಈ ತರ ನೀವು ಗ್ಲೋಬ್ ನೋಡಿರಬಹುದು. ಈ ತರ ಇರ್ತದ, ರೈಟ್? ಕ್ರಾಸ್ ಮೇಲೆ ಇರ್ತದೆ. ಸ್ಟ್ರೈಟ್ ಇಟ್ಟಿರಲ್ಲ, ಸ್ವಲ್ಪ ಡೊಂಕ ಮಾಡಿ ಇಟ್ಟಿರ್ತಾರೆ. ಈ ತರ, ರೈಟ್? ಇದು ನಾರ್ತ್ ಪೋಲ್ ಆಫ್ ದ ಅರ್ತ್, ಇದು ಸೌತ್ ಪೋಲ್ ಆಫ್ ದ ಅರ್ತ್ ಇತ್ತು ಅಂತಂದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ದಿಸ್ ಡೈರೆಕ್ಷನ್, ರೈಟ್? ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತಗೊಂಡೆ ನಾನು, ಈ ಪ್ಲೇನ್ ನಾವು ತಗೊಂಡೇನಿ. ಸೊ ದಿಸ್ ಈಸ್ ಅರ್ತ್ಸ್ ಟೋಟಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, BE. ನೋಡ್ರಿ, ಇಟ್ ಈಸ್ ನಾಟ್ ಅಲಾಂಗ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಎಕ್ಸ್ ಆರ್ ನಾಟ್ ಅಲಾಂಗ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ವೈ ಆರ್ ನಾಟ್ ಅಲಾಂಗ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಝೆಡ್. ಹೌದಾ? ಸೊ ಹೀಗಿದ್ದಾಗ ಈ ಪ್ಲೇನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಇದು ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ಗೂ ಇಲ್ಲ, ವೈ ಆಕ್ಸಿಸ್ಗೂ ಇಲ್ಲ, in the xy plane ಐತಿ. ಹಾಗಾದ್ರೆ ಏನು ಮಾಡಬೇಕಂದ್ರೆ we have to resolve resolution of a vector. Magnetic field is a vector quantity, right? When we resolve this one, so this quantity, this one, horizontal one, is called as BH. BH means horizontal component of Earth's magnetic field. Okay, so horizontal component of Earth's magnetic field is nothing but it is the component of Earth's total magnetic field in a horizontal direction. In a horizontal direction, that is BH. And here we'll have the vertically downward direction. So that is vertical component of Earth's magnetic field. And then second one, magnetic inclination or magnetic dip, means angle between Earth's total magnetic field, that is BE, and the horizontal component of Earth's magnetic field. So that is theta. Is it clear? So this is a schematic representation or schematic diagram. So here A, B, C angle is called as magnetic meridian, and the dotted lines AEED is called as geographic meridian, and AP is Earth's total magnetic field. AQ, that is BH, Earth's horizontal magnetic field. How can we write this Earth's horizontal magnetic field BH in terms of B? That is BH is equal to BB cos theta. Okay, or it has equation number 1. How can we write the vertical component? BB is equal to BE sin theta. Right? So at which place we can get the maximum horizontal component of Earth's magnetic field? Just substitute different values for theta. If theta is equal to 0 degree, then what happens? BH is equal to BE into cos 0 is 1. So this is maximum. Theta 0 ಯಾವಾಗ ಆಗ್ತದೆ? When this BE comes in this direction. ಇದು ಮೂವ್ ಆಯಿತು ಅಂದರೆ theta will become what? 0. ಹಾಗಾದರೆ ಯಾವ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹಿಂಗೆ ಬಂತು ಅಂತಂದ್ರೆ that is equator, right? Along whenever this BE comes to the equator, ಈ ತರ ಬಂತು ಅಂತಂದ್ರೆ there we can find the maximum horizontal component of Earth's magnetic field. So theta is equal to 0. This will get at equator. Then L horizontal component minimum ಇರ್ತದ. If theta is equal to 90 degree, then BH is equal to BE into cos 90 ಅಂದ್ರೆ 0. BE into 0 is 0. This is minimum value of horizontal component. L minimum ಇರ್ತದ. This theta should be 90 degree. 90 degree ಅಂತಂದ್ರೆ ಹೆಂಗಾಗಬೇಕು? ಇಲ್ಲ ಐತಲ್ಲ, ಈ ತರ ಬರಬೇಕು, ರೈಟ್? BE ಇಲ್ಲಿ ಬಂತು ಅಂತಂದ್ರೆ theta is 90 degree. So ಎಲ್ಲಿ ಬರ್ತದ 90 degree ಅಂತಂದ್ರೆ at the poles. At poles. ಹೆಸರು ಹೇಳ್ತದ ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೋನೆಂಟ್ ಅಂದ್ರೆ ಅಡ್ಡ ಈಕ್ವೇಟರ್ನಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರಬೇಕು. ಹಿಂಗೆ ಪೋಲಿಂಗ್ ಬಂದ್ರಿ ಅಂತಂದ್ರೆ ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೋನೆಂಟ್ 0 ಆಗಿರ್ತೈತಿ. ಮತ್ತು ಯಾವ ಕಾಂಪೋನೆಂಟ್ ಬರ್ತೈತೆ ಅಲ್ಲಿ? ವರ್ಟಿಕಲ್ ಕಾಂಪೋನೆಂಟ್ ಬರ್ತೈತಿ, ರೈಟ್? ಹಾಗಾದ್ರೆ ವರ್ಟಿಕಲ್ ಕಾಂಪೋನೆಂಟ್ ಎಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಮತ್ತು ಎಲ್ಲಿ ಮಿನಿಮಮ್ ಇರ್ತದೆ? ಇಲ್ಲಿ ಚೆಕ್. If theta is equal to 0 degree, then BB is equal to 0. Sin 0 is 0, right? So in theta 0 ಯಾವಾಗ ಬರುತ್ತೆ? At equator. At equator ಒಳಗೆ vertical component of Earth's magnetic field 0 ಇರ್ತದೆ. ಕ್ವಶನ್ ಬರ್ಬೋದು, where can you find the maximum vertical component of Earth's field or horizontal component of Earth's field? Where can you find the minimum value for horizontal component of Earth's field, vertical component of Earth's field? The questions ಬರ್ಬೋದು. Okay, at equator vertical component of Earth's field is 0. If theta is equal to 90 degrees, same case apply ಮಾಡಾತೀನಿ ನಾನು. Then BB is equal to BE sin 90 is 1. So this is what? Maximum. This is what? Minimum. So theta 90 degree ಅಂದ್ರೆ ಎಲ್ಲಿ? At poles. At poles, right? Poles ಒಳಗಡೆ BB maximum ಇರ್ತದೆ, BH 0 ಇರ್ತದೆ. At equator BB 0 ಇರ್ತದೆ, BH maximum ಇರ್ತದೆ. Is it clear? Then how to find out the magnitude of BE? The magnitude of BE. So look here, the magnitude of BE ಬೇಕು ಅಂತಂದ್ರೆ how this is equation 2. Square both equation 1 and 2 and add them. Equation 1 ಮತ್ತು 2 ಎರಡು ಎರಡನ್ನೂ ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಆ್ಯಡ್ ಮಾಡಬೇಕು. ಓಕೆ, ಯಾವ ಥರ ಆಗುತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ. ಫಸ್ಟ್ ಎಲ್ಲ ತಸ್ಕೊಂಡ್ಬಿಡ್ತೀನಿ ನಾನು. ಬಿ ಇ ಸ್ಕ್ವೇರ್ ಕಾಸ್ ಸ್ಕ್ವೇರ್ ಥೀಟಾ, ಬಿ ಇ ಸ್ಕ್ವೇರ್ ಕಾಸ್ ಸ್ಕ್ವೇರ್ ಥೀಟಾ ಪ್ಲಸ್ ಬಿ ಇ ಸ್ಕ್ವೇರ್ ಸೈನ್ ಸ್ಕ್ವೇರ್ ಥೀಟಾ. ಸೊ ಬಿ ಇ ಸ್ಕ್ವೇರ್ ಎರಡು ಕಡೆ ಬರೋದ್ರಿಂದ ಐ ಟೇಕ್ ದಟ್ ಆಸ್ ಅ ಕಾಮನ್, ದಟ್ ಈಸ್ sin square theta which is equal to RHS ಸಿಗೋದಿಲ್ಲ, BH square plus BV square, BH square plus BV square. cos square theta plus sin square theta value ಏನಾಗುತ್ತೆ 1 ಆಗಿದೆ. then BE square is equal to BH square plus BV square. But BE ಅಷ್ಟೇ ಸ್ಕ್ವೇರ್ ಬೇಡ, ಅವಾಗ ಏನು ಮಾಡಬೇಕು, and you take root on both sides. So under root, so BE is equal to under root BH square plus BV square. So like this you can get the magnitude of BE. Okay, then how can we get the direction ಹೆಂಗೆ ಬರ್ತದೆ, ಡೈರೆಕ್ಷನ್ ಆಫ್ ಅರ್ತ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಅವಾಗ ಏನು ಮಾಡಿ, ಇಕ್ವೇಷನ್ 2 ಡಿವೈಡೆಡ್ ಬೈ ಇಕ್ವೇಷನ್ 1 ಮಾಡಿ. ಓಕೆ, ಇಕ್ವೇಷನ್ 2 ಡಿವೈಡೆಡ್ ಬೈ ಇಕ್ವೇಷನ್ 1 ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಬಿ ಇ ಸೈನ್ ಥೀಟಾ ಡಿವೈಡೆಡ್ ಬೈ ಬಿ ಇ ಕಾಸ್ ಥೀಟಾ, ಬಿ ಬಿ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ, ಸೈನ್ ಥೀಟಾ ಬೈ ಕಾಸ್ ಥೀಟಾ, ಸೈನ್ ಥೀಟಾ ಬೈ ಕಾಸ್ ಥೀಟಾ ಅಂದರೆ ಟ್ಯಾನ್ ಥೀಟಾ which is equal to BV by BH, BV by BH. Okay, so ನೋಡ್ರಿ ಇಲ್ಲಿ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ ಟ್ಯಾನ್ ಈ ಕಡೆ ಹಾಕಿದ್ರೆ ಟ್ಯಾನ್ ನೋಸ್ ಆಗುತ್ತೆ. ಸೊ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ ನೋಡಿ, ಆಂಗಲ್ ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ ಡೈರೆಕ್ಷನ್ ಗೊತ್ತಾಗ್ತದೆ. ಓಕೆ, ಸೊ ಈ ಥೀಟಾ ಗೊತ್ತಾಯ್ತು ಅಂತಂದ್ರೆ ನೋಡಿ ಈ ಲೈನ್ ಏನಾಗ್ತದೆ, ಥೀಟಾ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ ವರ್ಟಿಕಲ್ ಟುವರ್ಡ್ಸ್ ವರ್ಟಿಕಲ್ ಬರುತ್ತೆ, ಥೀಟಾ ಡಿಕ್ರೀಸ್ ಆದಂಗೆ ಟುವರ್ಡ್ಸ್ ಹರಿಸಾಂಟಲ್ ಹೋಗುತ್ತೆ. ಅವಾಗ ಏನು ಗೊತ್ತಾಗತ್ತೆ ನಮಗೆ, ದ ಡೈರೆಕ್ಷನ್, ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಐತಿ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಓಕೆ.